Well, hey everyone, it's another Toolbox Tech Talk here at the Smart Energy Lab this Sunday. Great to be back, and today I've got a very special guest, someone I've known for a few years now, and he kind of reached out to me through some energy management tech that he's involved in, but we've kind of gone beyond that. So there's a little bit of cryptocurrency mining, there's a little bit of control systems, and there's how to make solar earn you some more. So this chat with Sam Frost, it was really good, and he brought along some of his spiced rum, because our Toolbox Tech Talks, when they're recorded in my studio, we often have a bit of a kickback. So enjoy this chat with Sam Frost, and I'll see you on the other side. Over to you, Sam.
I was referred to you, I think, from someone that was doing some work for me a year or so back, I think now. So they mentioned that you do YouTube videos and talk about new products in the solar industry and that sort of things. And so I reached out to yourself to see whether you'd be interested in doing something on the Smappee equipment that we were offering.
That's right. And then I kind of realized I already had some.
From Vata, wasn't it? Yeah.
Vata had sent me like a care package, really.
Yeah.
It just felt like that, because they were, very supportive of the lab and provided me with, their pulse unit, and they said, "Would you like our monitoring system that we associate with called Smappee?" And I thought I didn't know anything about Smappee back then. And they sent me a box of tricks, which was the older Smappee. So
the Smappee Energy, or solar,
Yep. Cool. Well, that's how we kind of met. And we've got another commonality, which happens to be on the shelf.
Yeah.
Now, look, you're to blame for my obsession with cryptocurrencies. It's not a real...
I'll take that.
It's not a huge obsession, but it certainly gets me up in the morning, and I just open CoinEx and have a look and see what the exchange is doing, and see what the price is today, and go out and turn my miner on.
Yeah.
When the sun
Soak
comes
up that solar.
That solar.
I mean, it's a very interesting space, and there's also not many things in this world that not many sort of machines or anything that you can literally turn on and pump power into and essentially make money. Currency. It's quite an interesting and cool solution. Yeah, definitely. I can see why you're interested in it.
Do you enjoy that blank look when you say to people that you have a crypto miner at home or a Bitcoin miner at home?
Yeah. It means I kind of, if I get a blank face, then it means that I'm going to be doing a whole lot of talking for the next half hour or so. Whether they like it or not, yeah.
But actually, you've given me a kind of an excuse or a fallback position, which is actually I'm not interested in the cryptocurrency at all. It's just a load dump for me, because for real, here at the Smart Energy Lab, we've got surplus generation during the day, and because a lot of systems here I'm testing and I need to model their performance, like we just went out and looked at the Inga Team system, which actually was on the podcast last week, and they don't want me to put it on the wall and sit there fully charged doing nothing. They want to actually see how it works, and I need the data. So actually having some loads I can just turn on and off. I was using heaters. So I was just using, electric heaters, but they don't generate anything.
You're throwing it away, aren't you? So.
Yeah. So that's kind of been fun. But let's go way back. So how did you kind of come to be involved with energy?
With energy, it was basically just where I was working at the time. I moved to Australia from New Zealand in 2005 and started working with ABB, basically in their warehouse, picking and packing orders, and have always had, I guess, a bit of an interest in electronics and that sort of things, and so I was pumped to get a job there and be working there, and then sort of moved moved upwards from there into more customer service and sales, and did a little bit of PLC and automation study at Swinburne, and it's just been I think about 15 or 16 years now, just working in the space, and then learning about load control, load management, and that sort of things from my most previous role with a generator and load management control company. That was where I sort of got a lot more involved, and then obviously with the solar boom happening and all of the new technologies coming out there, it's one of those things that if you are interested in it, you can't you can't not be involved in it, because it's everywhere, and it's just such an important part of life at the moment, the economy, and with everything going on with the climate as well, and you can be involved in the energy space, and you sort of feel, especially like when you're working with green energy or energy efficiency, you get a feeling like you're doing a little bit of good at the same time, which is good.
I often say that when you work in this sort of solar industry, you get a halo. Automatically, you get this halo, even if you're a bit of a badass kind of personality. You're doing good, whether you like it or not, because it is true. It is renewable energy. It's not damaging the climate. It's actually helping people transit to a better world. So you get that. But you mentioned learning about PLCs at Swinburne. Were you at the Wantirna campus?
Yes, I was. Yeah,
at that new building, the environment building at the front.
I was. Did you build that?
I taught there.
You taught there, yeah.
In fact, I did installed all the training systems there too.
The Allen Bradley equipment.
No, not the PLCs.
Oh, okay.
All the solar stuff.
Oh, yeah, okay, yeah, because they had some wind turbines there.
I did that.
Or a wind turbine. Yeah, okay. Oh, cool. Yeah, excellent.
That was me.
Yeah.
In fact, I've got a spare one out in the shed here.
Oh.
So that's a Southwest Wind Power Grid Connect turbine. It was actually the only type of Grid Connect turbine available at the time.
Yeah, okay.
Probably still is, because it was 4777 approved.
So Grid Connect so it has an inverter that comes with it
in the
unit,
in the nacelle. So it's just AC down the.
So it's like a micro inverter type scenario.
2.4 kilowatt inverter.
Yeah.
So it was a big ass thing, and it weighed like 78 kilos, the nacelle. And I remember putting that up in the courtyard on a Saturday with my team was a bit of a scary moment.
Yeah, you would have wanted to make sure it's the base was engineered correctly. Yeah.
Well, that's funny. All right, so we share Wantirna. I remember that building too, because it sort of. I think you probably had it in its heyday. I think the PLC stuff kind of fell away. There was a loss of interest in it, actually.
Oh, okay. Yeah.
Well done.
It was a great setup. There was pump and level control, and I think some sort of mechatronics stuff as well. So it was really interesting. Yeah.
Now, we just used some TLAs then, 3-letter acronyms. So we better explain, what's a PLC?
So PLC is a programmable logic controller. So it's basically an industrial computer to a certain extent, but it's made for controlling inputs and outputs, so that it interacts with machinery and plant and that sort of thing. So you would you'd use a PLC in a circumstance where, say, you had an industrial pump that needed to run when a tank level got to a certain level, and so you would then be able to add some logic within that PLC to say, when sensor A or high level sensor turns on, turn off the pump, and vice versa, and that sort of things. And I mean, in industry, PLCs are what run huge production equipment, and they're just everywhere in the industrial world. So it's quite an interesting space. And there's a lot going on as well now with IoT and sort of PLCs being leveraged to work on with the Internet of Things and that side of things as well. So it's quite cool.
I can see why Smappee appealed to you.
Yeah. So Smappee reached out to me, and when I learnt about the product, I was really excited because I'd been working in a space where we were developing load management systems for large commercial buildings, where certain things needed to happen if there was a power outage. Generators needed to come online, certain circuit breakers needed to be isolated off the grid and switched across to generator supply and all that sort of thing. So when I found out about Smappee, it was like, wow, this is something that's packaged up and it's something that you can install like in a home or a business. It's it's sort of pre-made to do all of that stuff. So it was really interesting, and it's been exciting working with the product and seeing what it can do.
So is Smappee a PLC?
Smappee is more of a, I guess you could look at it like a commercial Raspberry Pi. It's a system and it uses a Linux-based processor, and so it's pre-programmed, but it does work in a similar way to a PLC, with controlling inputs and outputs. But it's more user-friendly. It's more of a plug-and-play solution. You don't have to jump on to your computer and write sort of logic or codes for it. It sort of does all that intuitively. So it's like a PLC system, but more for for anyone to sort of get their hands on and use. Yeah.
Right. Yeah. So it's a system in a box basically, without all the techie geeky stuff.
Yeah, and without the tens of thousands of dollar price tag that you get with industrial control equipment. Yeah.
Now, look, we have talked about something. I just brought up the webpage for Smappee, so people are aware of what we're talking about. But what I got here is which one here? It's some of the kit that you supplied the lab.
Oh, cool.
So what we've got there, let's have a little look.
Okay, we've got a bunch of current clamps or current transformers. So these are pretty straightforward. So they basically clip onto I'm not sure which camera, but yeah, they clip onto the cable or the conductor that you're looking to monitor. So basically, just clips over the cable like so, and and then they connect to what else have we got in here? So this is the Smappee Solar.
I've got another box.
Another one. There's a lot of bits and pieces.
And there's also the pre-built unit that you have down below.
Yeah. Cool.
It's probably in the pre-built unit there.
Yeah, so there's a CT hub, which I don't think there's any in this one. Not sure where they are, but yeah, so the CTs connect to that, and then they all connect to a power monitoring device. So with traditional metering, you'd have multiple meters monitoring different circuits and that sort of things, whereas this brings all of the information into the one device. So you only have to connect it to one power supply, and then it communicates to the gateway here, which would be what you'd consider like your PLC type device, and then that device has some internal logic. So when you create control rules to say if solar production goes above 2 kilowatts, turn on the pool pump, it will do that internally, and then it also has a communications gateway built into it.
Or the miner.
Or the miner, yeah. Well, make a bit more money that way.
So this unit we're looking at here is not Smappee. This is just an electrical enclosure.
Correct. Yeah. So the Smappee equipment is all of these modules. So it's a modular arrangement. So you really build it up to what you require. You could put it in a home and monitor your grid and your solar production, and that's that, or you could add it to a commercial site and control multiple circuits based on solar production or time or different things like that. Yeah.
So the box that we've got in front of us here, there's a whole lot of stuff in it. These are mostly CTs, right? So you're taking the source information, which is current and voltage, direction of flow, and there's also the other modules for things like water and gas too, isn't there?
Yeah, correct. Yeah,
we don't have those here because we don't need them. But
well, there's one. There's the so the input module here that will connect to the pulse output on any gas or water meter or another electricity meter. So you can basically bring that data in to the cloud reporting.
So it's a pulse counter.
Correct. Yeah.
Wow.
Or a state monitor. So it'll either monitor the state of an output, or it can count pulses as well.
Right. Wow. Okay. Cool. So just from left to right here, I know it's a bit difficult for you to see from the side there. The green box here, what's that one?
So that's the power box. It's essentially a Modbus power meter, but it works in a modular way where you connect up to 28 current clamps to it. You can essentially install one of these systems in a home and monitor every single circuit in the home.
Wow. So 28 of these, which are very compact. So that looks like it'll take maybe a 16 mil cable?
10 mil? Yeah. So it'll monitor 50 amps, that one. Okay. So 10 millimeter diameter.
Yeah, you probably get single insulated 16 mil through there at a pinch, but 10 mil double insulated. So you can put those onto all the actives of the circuits you want to monitor. Up to 28, was it?
Correct. Yeah.
Wow.
And and it works with single and three phase as well. So, which is quite cool.
And where does it get its voltage reference from?
The voltage reference is these cables here. So the device and the whole system actually is powered from the line 1 and neutral connection here. And then if you have three phase, you can also add line 2 and 3 as well.
Right. Okay. I noticed on screen there's some other things like EV charging. Yeah,
that's right. Yeah. So Smappee have just released this year a range of commercial EV chargers, and so a dual three-phase charger that does 22 kilowatt, 222 kilowatt outputs. And they've actually this month also released a wall mount unit for single phase and three phase charging in homes and small business. And the really cool thing about their chargers is they fully integrate with the Infinity system. So you can add smart control to charging, and when you look at electrical loads, EVs are one of the larger loads that people would be sort of using in a day-to-day.
There's not many 22 kilowatt loads in a home.
Exactly. Yeah. So that's where that smart control will really be quite useful, because choosing to charge during off-peak rates or purely off solar. That's where that smart control can really work well. And the Infinity system also has a feature called Smart EV Charging built into it. So you have the capability to set a time and a charge level. So you might say by 7 o'clock in the morning, I need 200 kilometers worth of charge, and the unit, the Genius Gateway there, will determine, so it'll look at your electricity tariffs, and if you're on a higher tariff, it will only charge off solar power. So it'll actually vary the output of the charger, so it only uses excess solar during the day, and then once solar drops off, it will then wait until 11 o'clock at night when your tariff changes, and then it'll top up overnight.
This just makes it so simple, which is you say what you want to achieve, and it works out the cheapest way to achieve it for you.
Exactly. Yeah, exactly.
Oh,
yeah,
I love it.
Yeah, and it's as simple as basically in the app just choosing to turn on smart charging. You don't have to set parameters or anything like that. It just does it all for you. So yeah, it's really really interesting, and I'm really excited as well with the EV space growing quite quickly. It's still in its infancy in Australia, but it's definitely growing. I think EV sales are doubling year on year at the moment. So it'll be really great to see this technology used out there.
You're talking to the converted here. So as you know, we recently bought an EV, our family did. And just for the viewers' information, we actually have a large array out in the paddock here. It's a 70 kilowatt array, only half finished at the moment. So we actually have a lot of surplus power, but only when the sun is shining. So our challenge is, how do we charge vehicles when there's surplus solar? Because we have a relatively small storage unit. But the problem was that as soon as we bought an EV, two other of our community members bought an EV, and one of them has a hybrid as well. So we've actually got 3 vehicles that want to charge at 7.4 kilowatts. So it's a little bit of a challenge managing that so that they don't start discharging our battery pack. So we're off-grid here, and we're basically a microgrid. And so it's done totally manually, which is, I'm checking the app to see if the batteries are discharging, go and turn off with a switch the EV because it's, sucking the batteries because the sun's gone behind a cloud. But Smappee will just work all that out for me, won't it?
Yeah. I was getting more and more excited to to tell you that. So so part of the functionality with the Smappee Infinity system and working with the chargers is you can set a maximum current to charge to. Or the maximum current that a certain circuit or the supply circuit can provide. And if you add multiple charges to that circuit, it will level out the charges so that it never goes above that level. So if you're charging one EV, it'll charge, say, at its max. But if you're charging 4, it'll run them all at, say, a third capacity or a quarter capacity, depending on what you've set the limit to. So yeah, it's really great in that sense. And also in commercial scenarios where you've got an existing supply, the building's towards its limit to the transformer. Instead of upgrading the transformer for $50,000 or $100,000 to allow for EV charging, you could basically use that smart control to level out the charging across all of the charges. So that way, in the case that you do have 5, 10 vehicles charging at the same time, it will manage that and not blow your fuse. So
EVs have introduced this new problem, which is capacity limits. I mean, most homes don't have massive instantaneous loads like an electric vehicle, but now we have to manage that, whether it's because your connection to the grid is weak or whether your tariffs will be blowing your peak, for instance, because we're now seeing peak demand tariffs starting to edge down to the residential level in some jurisdictions in Australia. So you really need to manage your energy demand as well as your energy usage. And so devices that can do this, like Smappee, is going to take the hard part out of it.
Yeah, definitely. Yeah, I mean, in a home setting, so not even taking into account just EV charging, you might have other loads. You might be turning your oven on in the evening while your EV charger's connected as well, and might be heating water or running some other loads. And so it won't just look at the EV charging loads. It'll look at the overall site, and if you have a limit set on that Grid Connect circuit breaker, it will level the EV charger so that the total import never goes above a certain level. So it's a really cool technology. Yeah.
And I love the plug and playness of it. So the fact that you've got one power supply that daisy chains to all the other devices. And it's just a RJ11 or 12 connector.
RJ11. Yeah.
So RJ11 connector, basically your old phone connectors, which is providing the power, but also it's the Modbus.
Yeah, that's right. Yeah, Modbus. So it's got 12 volt power that comes out of the power box to the other devices.
Yep.
And then also the Modbus pair. And so that can go up to 100 meters, I believe, as well. So between this device and any input modules to the gateway, you can have 100 meters. So you could have output modules located in different areas, that kind of thing, and also the CTs as well. That bus can be up to 100 meters as well. So you could be monitoring, 5 circuits or 10 circuits in one switchboard, and then you might have a subboard on the other end of the house, so you can just run a cable down and add CTs down there. So yeah, it's a really versatile system. Yeah.
Cool. I love it.
Yeah. No, it is pretty cool. Yeah.
I should point out that I think I said this before, but this enclosure isn't part of the Smappee system. This is something that you've built, but you could put all that inside a switchboard with segregation, of course, or any other enclosure, because it's all extra low voltage except for when you've got the AC coming in here for monitoring.
Yeah, that's right. Yeah, exactly. So you could even install the power box on the DIN rail inside your switchboard next to your circuit breakers.
Yep.
And then run the comms cable out of there to your other devices that could be in a small enclosure outside of the switchboard or somewhere else. The Genius Gateway, it has a radio frequency receiver and transmitter for wireless control of those Smappee switches as well. And so the reason why it's best to install this outside of the switchboard is so that you're not impeding the radio frequency signal.
So this is the Smappee switch?
That's one of the European type plugs. Yeah, so
Yep.
the same principle, but the switches are a small extension lead that can attach to any.
I think they're in the other box actually, but it looks like a little a bulge on a. Oh, maybe it's in another box yet.
Yeah, it must be something.
I've got so many boxes. Thanks to you, Sam. Yeah, it is deceptively sophisticated. So it looks like just some CTs, just some little white boxes and little connections, but it's often it is the smarts that you put into something. Like your phone looks deceptively simple. No, it doesn't. But anyway, it's amazing what's in there. Those kind of smarts are built into the Smappee system. Yeah,
exactly. Yeah, I mean. And being an IoT device with the Linux processor, it means that it's more of a coding sort of platform. So you can even request Smappee to add custom code. So if you have a third-party Modbus device that you'd like to connect to, Smappee can actually add custom code, Python code, I think it is, to the device so that it can interact with other equipment and that. So it's being essentially like a Linux processing scenario. It's like a small sort of server PC or something like that. Which is very cool.
You just used another TLA, IoT.
IoT, Internet of Things, yeah. So, which is basically the idea of so instead of traditional industrial control with PLC equipment and that sort of things, you would have equipment talking to other devices on a local network or by other industrial protocols like Modbus. Whereas Internet of Things allows for smart devices to connect to one another anywhere in the world through APIs and there's another one.
the world is full of TLAs. Look, I just it's kind of one of my missions in life is to help explain TLAs, 3-letter acronyms. What's a TLA? I mean, what's a API?
API. To be honest, I actually don't.
Application Programming Interface.
Interface, yeah. Okay, you'd know more about that with the solar tracking business, yeah.
Actually, I'm a bit of a Linux hacker, so
cool.
That's kind of where I'm familiar with that. So I guess, so APIs are a way of discrete products without any commercial arrangement talking to each other because there's some open communication strategies, and that's what an API is. So it's a good example might be that your accounting software talks to your design software through an API, and they're both made by different entities.
Yeah. It's I guess like sending messages to one another that each device knows what to understand. So you would program in one device. If I get a message saying apples, I know what information that device is sending me, and so then it might be a number of apples, and it can then do something with that information. So it's a really cool technology, and it opens up huge capabilities with different smart devices being able to work with one another. There's the if this and that platform, which is really interesting. So that uses that API technology to allow you to connect one smart device to another. So with the Smappee Infinity system, you could, through the if this and that platform, create a rule to say if solar production gets above 2 kilowatts, or if export to the grid gets above 1,000 watts, turn down the temperature on the smart air conditioning controller. There's a device from a company called Sensibo, which we've installed one at home, and it's just great. You can basically use an app, a smartphone app, and you can log in. So if you forget to turn the air conditioning off, you can jump on and turn that off. But yeah, the great thing is it works as an IoT device, so it can work with other smart devices for sort of more advanced control and automatic control, which is cool.
I just love the name. If this, then that. So it's so logical, this is what you want to do. If product number 1 does this via the cloud service, if this, then that, then you can do that. And that might send to another device to do something else. So
it makes something, it's doing something quite complicated or quite complex, but it makes it really straightforward, just like the name. I've been a subscriber to this and that for a while, so yeah, that's pretty cool. Hey, I'm just going to pass me that device there. I'm just going to put it down for a second. So look, there's a couple of things we're going to talk about this evening or this afternoon or whatever time zone we happen to be in, because I never know when people are listening to these podcasts. But the other thing we got sort of a bit excited about, thanks to you, was cryptocurrency and Bitcoin mining. Now, how did you get into that? How did I get into that? The first time I heard about Bitcoin was actually back when it was, I think, a number of cents per Bitcoin, and I am absolutely kicking myself that I didn't look into it further. So I actually I read about it on a blog or something somewhere, and I went to the extent where I downloaded and installed a wallet on my phone, on my laptop, but I think I looked at mining it, because you could basically run a program on your laptop to mine Bitcoin, and I looked at the number of cents and I was thinking, well, geez, it's only going to make 5 cents a day if I'm doing this, so what's the point? And then about sort of I don't know, like 8 years later, when the price was, I think, around 2,500, I was thinking, hang on a minute, like I actually, I did something with Bitcoin, and so I found the old hard drive and that. And
didn't throw it in the dumpster? No,
I hadn't thrown it away, but unfortunately, I never actually started mining with it, so I didn't have anything. Thinking about what things could have been. So I got a bit more involved in cryptocurrency in 2016. I purchased some, and it was going really well, and so then I decided to invest in some mining equipment, so that the ASIC miners, like the one up on the shelf there, and leased a small factory and started running those in there. So unfortunately, it all worked. That my timing wasn't so great, and probably my calculations weren't the best. So I set everything up. I put 20 kilowatts of solar on the factory roof.
Wow!
And also received my first power bill prior to putting the solar on the roof, and it ended up being I think my first power bill was about $12,000, and this all coincided at exactly the same time as the 2017 cryptocurrency crash. So I basically had to sell pretty much all the crypto that I had to cover the cost of the solar, the electricity and all of that. And then I was in a position where it wasn't actually profitable to be mining it. So yeah, it didn't go the way that I was hoping, but my interest in the space and the technology has continued in that, and so and I'm really excited as well about some of the smart things that you can now do with the Smappee system and adding control based on solar production. So I'm still, at the moment, I'm mining Litecoin in one of the rooms in my house. So down at the other end of the house, because they're quite loud and pump out quite a lot of heat. So I'm really excited about what can be done to make cryptocurrency mining better. So at the moment, it does use a huge amount of electricity to mine Bitcoin. I think the number of terawatts that the Bitcoin network is using is just enormous. The good thing is, I believe about 70% of cryptocurrency mining is done with renewable energy. Which is good.
Wow.
Yeah. So because the cost of electricity, burning fossil fuels and that side of things is quite expensive these days, and where you've got wind turbines or solar set up, you're essentially able to use that energy for free. And if Bitcoin mining is paying any better than what the price of electricity is, then it makes more sense to mine crypto than to sell it to the grid. So there's a lot of mining going, especially in northern Europe, where it's really cold as well, and they have a lot of wind turbines and that sort of things. They're doing a lot there. But one thing that interests me is cryptocurrency and Bitcoin. The whole point of it is decentralization. So instead of one entity managing everything or managing the network, it's everyone that's connected to the network is a part of it and helps to keep it running. At the moment, Bitcoin mining isn't decentralized. It is mainly done in large mining farms where you've got thousands of miners and that sort of thing set up. What I think would be really interesting is to decentralize Bitcoin mining as well, and actually put that into households. And so, you look at it's well over 1 million solar installs in Australia.
More than 2.3, I think it is.
Yeah, exactly.
25% of the homes.
Exactly, yeah. So you've got all of the solar production going on in Australia in homes, and the feed-in tariffs slowly coming down more and more. Whereas if you could be running a Bitcoin miner and be getting paid 30 cents per kilowatt hour, then it makes more sense to do that. And there's also the benefit as well to the actual grid stability. Because if you're looking at wholesale electricity rates, essentially when there's more demand on the grid, the price goes up. So you wouldn't mine during those times, but when there's low demand on the grid, you can have issues with too much solar being fed into the grid and causing over voltage on the network and that sort of thing. So having behind the meter loads to utilize that solar instead of just turning off the inverter, it's not just benefiting the person that's mining Bitcoin, it's also benefiting the network and everyone that's on the network. So there's some really interesting I think potential for where things could go with Bitcoin mining in the future.
So just the other day, actually in one of my courses, I had someone who's involved in utility scale solar, and they were saying, like, we've now got so much solar on our networks in Australia that negative pricing is a problem. And so they've got, a 250 megawatt solar farm they have to turn off because otherwise they'd have to pay to export the energy, because that's what negative pricing means. Now, you've got a 250 megawatt generator that you have to turn off. Surely there's a better option.
Yeah, exactly. Especially when you consider how much would have been put in, like the initial investment in that, and to have to turn that off because the network can't handle it. You're right. So to be able to even run some of that power on something else that can make you the same, if not more money, would it makes sense.
Yeah, it makes sense. Let's take a couple of steps back. So, there's kind of like two avenues we can go down, which is what is a cryptocurrency, Bitcoin being just one of thousands of cryptocurrencies, but something like 2/3 of the market or more, but it's the most well-known one. But then there's the way that it's actually generated. Now, I deliberately stuck this S9 miner here on the desk so we could look at one. You don't actually have to use one of these. You could use your computer at home, couldn't you?
Yeah, you could, but to produce the same amount of Bitcoin as one of these with your computer would take, I think it would be years. So,
sorry, it's years per day. Like this in a day would.
Yeah, exactly. So one day of mining with this would be the equivalent of mining for. I'm pretty sure it would be well over a year on a what is it 7. Yeah,
CPU. A U-Boot CPU.
Yeah, exactly. So, these are an ASIC miner, and I can't remember that TLA off the top of my head. You might be able to Google that one.
Application-specific integrated circuit.
Oh, there you go. Yeah. So
my special power is acronyms.
Yeah. So, and I think you pulled one of these apart. So, the inner workings of these. Basically, it's just a whole lot of computer chips that have been manufactured for the specific purpose of mining Bitcoin. So it basically runs a certain set of algorithms, I guess, or calculations purely to run that SHA-256 hashing algorithm, which is what Bitcoin uses. And so because of that, because it's purpose built for that application, it operates much, much faster than a standard computer CPU that's made for doing all sorts of different applications and that sort of things.
Yeah, so I did actually open this up to clean it actually, because one of the problems is they suck in a lot of dust, and thank you for supplying these, but this one got quite dusty, and there's 189 chips, and each chip is effectively a independent miner. So you've got 189 little devices inside this that are mining as fast as they can and doing nothing else. They're not providing any graphics for you or any control of your peripherals. They just go hash, 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 hash. And so that's their role. These are quite old ones, being S9s. What we're up to, S19 now?
S19, yeah. So to give you an example, so these at the moment, I'm running a few of these, and they are producing, I think it's about $3 a day in revenue on top of electricity costs. The new generation, the S19, so these mine at a rate of 13.5 terahash. Actually, if you use the third party, the Brains OS software, you can get about 15 to 17 terahash out of them, and they use about 1,400 watts of electricity. The S19 Pro, that does 110 terahash and uses just over double the amount of electricity. So, yeah, the efficiency in the chips has come a really long way. Yeah.
Yeah. So these are effectively, from my perspective, a 1,400 watt load dump, which happens to generate. I don't have to worry about the price of electricity, so more like $5 or $6 a day, just sitting there for test purposes. Also, have to provide is an Ethernet port and a 230 volt connection. Nothing else. It's so simple. Like, you just plug it in, turn it on, walk away. There's no launch a program, log in, nothing like that. Turn it on, walk away.
The only thing that you do want to make sure you do is put your own Bitcoin address.
Yeah, I did mine for you for a few days.
Thanks for that. Yeah. Yeah.
So it does actually have a browser interface that you can log into and then set all the parameters, such like, where your pool is and who you're mining for, and
yeah, correct. Yeah. And I suppose talking, you mentioned pool. So there's a couple of ways that you can also mine Bitcoin with an ASIC miner or any device. You can mine it on your own, and if you do that, then essentially the profitability is the same per hash that you're doing, but the chance of finding a Bitcoin is going to be much, much lower. So, you could run solo and you might mine for, I think these days you'd be mining for well over a year, probably a few years before you actually had a chance of finding a Bitcoin. Whereas when you combine that mining power with thousands of other people, that pool will find a Bitcoin more quickly, and then everyone gets a small cut of that based on the amount of mining power that they've provided. So, yeah, it's interesting. It's a cool community setup.
It's like taking all your friends to the pokies and then pooling your wins.
Yeah, yeah, exactly. It is, a bit like that. Yeah. For some reason, I don't like those odds.
No, because what is it? 40% goes to the owner of the premises.
Yeah.
On average. So I'm not a supporter of gambling, and so people often think that mining Bitcoin is some kind of dodgy, illegal, dark side of the web thing. What's all that about?
So originally, I guess. Not the technology, but the use for it was used primarily for the purpose of purchasing illicit substances or hiring someone to do something bad. Because Bitcoin it's a digital currency. There's nothing tying you to the transaction. People were able to use that anonymously to make payments. There is the funny thing is, Bitcoin transactions are completely transparent. So you can log on to a browser and you can search for a transaction ID, and you can go through every single transaction that has ever happened on the Bitcoin network. But unless you know who owns the wallet that transaction has come from, then that person is unidentifiable. But there have been ways to link people to their wallets. So that has happened, I think, for basically tax purposes and that sort of things. I'm pretty sure the tax man has a pretty keen eye on cryptocurrency at the moment. So there are ways to identify who's made that transaction. But so that's where it sort of all came from. It was being used on like I think there was a website called the Silk Road or something like that, which was like eBay for criminals. But now it's now you're seeing institutional investment. Tesla, I think, just bought $1.5 billion worth of Bitcoin, and there's now companies and investors that are investing in Bitcoin as a store of wealth that is protected from what the dollar does. So if there's any hyperinflation or anything like that happens to any currency, fiat currency, then they've sort of protected themselves from that in a similar way to what gold has been used for in the past.
A couple of things. You used a new term there, fiat currency. What's that?
So fiat currency is just basically your standard currency. You're talking like Oz dollars, US dollars, euro. So the reserve bank currencies, essentially.
Right, yeah. And the other thing is you said that Bitcoin as a cryptocurrency had been used for illicit purposes. I think cash has been used for illicit purposes too, but we don't kind of have a dark view of cash.
Yeah, that's right. And the thing is, if someone sort of shady does a shady deal and hands someone $10,000 and they take that, there actually isn't any record of that ever happening. Whereas with Bitcoin and blockchain, there is a record of every single transaction that happens. So there's evidence there, and it might be a matter of connecting some other dots, but the transaction is viewable to everyone.
You mean if you were, through some legal means, found out their wallet address, you could track where the transactions had occurred?
Exactly. Yeah, that's right. Yeah.
All right. Wow. Okay, cool. Hey, that's really nice. I'll just pop my glass there. So, Sam, I'm actually learning stuff while we're talking here. So I'm actually not. I'm a real cryptocurrency newbie, so I ask the dumb questions because I'm a bit dumb about it. But it's been really interesting for me, not just from an economics point of view of earning a bit of money, wasting some surplus solar power, but that actually it's providing an alternative to what we think of is a legitimate way of funding our lives. This is actually possibly empowering people who don't have bank accounts, for instance. I mean, it's got a social dimension to it, hasn't it?
Yeah, definitely. If you look as well, I mean, Australia is a fairly well-off country when you look at ourselves compared to a lot of other countries in the world. And I think it's Venezuela. Was it Venezuela? I think, and there's I believe a country in Africa now that have been relying on Bitcoin. So they've basically been buying Bitcoin because it's retaining its value, whereas their currencies have undergone hyperinflation and so is becoming worth nothing. And so it's actually having a really positive impact on communities that are going through some sort of quite negative financial situations. The other thing about it is, if you think about purchasing something from overseas, so say you jump on eBay and you want to buy something from America. Traditionally, to get funds across to that person, you have to bring in a third party. You have to bring in the bank or a financial institution, and you say to them, "Hey, I want to turn this many Oz dollars into US dollars. What price can you give me?" And they lick their lips and go, we'll give you this exchange rate, which isn't the actual exchange rate. So they make a cut from that and then charge fees and everything. And that might take, I think these days it's not too bad. It might go on the next day. But in the past, it would take days to transfer across. Whereas with Bitcoin, you can make a Bitcoin transaction. It'll cost you a few dollars to do so. And you'll start to see confirmations of that transaction within minutes. So, from that side of things, it just opens up international trade and allows people to deal directly with one another without needing to bring in a third party that's always going to take a small cut of that.
Yeah, so my experience of this process with fiat currency has been, I have quite a few international students doing my courses, and I had this guy from Nigeria, and he was lovely.
That's the country, is it? I think Nigeria is the one that are using Bitcoin now as in place of their fiat. Yeah,
Okay.
Exactly. Yeah.
Well, this is before I even knew about Bitcoin, and he wanted to pay me, and so the only way he could do it, because he didn't have a legitimate bank account, I don't mean legitimate. He didn't have a bank account. He had money in cash, and so he wanted to transfer it to me. He had to go through Western Union. And you got a mosquito on your head, by the way.
Oop.
Yeah, we might get rid of them. They're endangered species here, so just gently wipe it away. So he had to go through all these hoops. I remember, finding there was a fee for it. He had to go to a special place to do the transaction. I had to then go to drive 50 kilometres to basically a corner store in suburbia, who would then hand out the cash over the counter to me. The whole process was just like 19th century, 18th century transaction, and expensive, difficult, but with a blockchain system. Now, we've been saying Bitcoin, but there are lots of cryptocurrencies. In fact, Bitcoin's probably better suited to holding and storing value as opposed to day-to-day trading, isn't it?
Yeah, that's right. So there's alternatives like Litecoin. There's even US dollar Tether, which is basically backed by the US dollar. So and I believe that there's other Tether currencies coming out, like one to the euro, to the Oz dollar, and that side of things as well. But yeah, so Bitcoin is, I guess, considered your gold standard. It's what you buy, you hold on to, and you retain that as an asset.
We're looking at it here on the screen at the moment. It's probably what is it doing? It's going up and down, but as it does, something like $58,000 US dollars a Bitcoin at the moment. I don't want to rub it in, but what was it when you started?
When I started, it was $5,000 when $2,500. Oh no, when I first looked at it, it was like 3 cents or something like that.
3 cents a Bitcoin. I can't believe that.
Yeah,
My God.
yeah.
All right, so I've lost track of the levels of magnitude that it's gone up.
The only thing that makes me feel better about that is knowing that there's someone that threw a $70 million hard drive in the dump. So like, yeah, I mean, there's some stories out there. Yeah.
Yeah, life is always more tragic in retrospect when you could have made better choices. But actually, you didn't suffer. You just missed opportunities. Some people win, some people lose.
Yeah, it was a lesson. It was an expensive lesson, but it was a lesson.
So let's kind of go full circle here. So tie this back into our core sort of interests, which has been renewables and control. Now, why is renewables and control systems like Smappee got some connection with cryptocurrency mining? Well,
basically because there's a direct connection with cryptocurrency mining and energy consumption. So, to mine a certain amount of Bitcoin or Litecoin or any cryptocurrency, it's going to use a certain amount of electricity per hash or something. So you can work out a cost per kilowatt hour or a return per kilowatt hour. And yeah, the other cool thing is the fact that ASIC miners in particular, you can power them on and off as needed. So there's no manual startup or shutdown process like there is with your PC. You can basically just turn the power off when you don't want to mine, and you can turn it back on when you do want to mine. And there's now new energy services or energy retailers out there that are offering wholesale electricity prices directly to the public. So that means instead of paying a fixed rate or a time of use rate like we pay traditional retailers, you can gain access directly to the wholesale market rates, which are usually sit very, very low, but they can sometimes peak quite high. So so there's low cost electricity available, and the reason that it's low cost is because of the uptake of solar and renewables in Australia, and so that's helping to bring down the average cost of electricity. And then you've got solar installs on homes, on businesses, and that side of things, and so if you can add smart control, so if you had a couple of these running in your home, you can install a Smappee system. You've got solar. You could basically create a rule to say if solar production is above 3 kilowatts, turn on 2 ASIC miners and run them, and you might be getting paid. With the S19s, with the new ones, you'd be getting paid 30 something cents. It might even be 40 cents. It's with the price of electricity now. So you're getting up towards that premium.
40 cents a kilowatt hour.
Yeah, that's right. Yeah. So with the way that the market's going and the way that it's increasing, the payback on mining is quite high, and when you compare that to your feed-in tariffs, which I think they're often down around 10% now. 10 cents. It makes a lot of sense. So there is a reasonable investment. I think the S19 miners are selling for around $5,000 at the moment, but they're set to. I believe they say that they should go for over 5 years. So 5 years of mining, and at that sort of payback, you should make a lot more than what your initial investment is, provided the Bitcoin market continues to at least go sideways. So.
I think this is where we insert the usual comment, we're not providing financial advice.
Yeah, that's the one.
That's right.
Yeah.
We'll stick that at the beginning, I think. But anyway, we're not providing financial advice. We're just riding and rolling with the market and learning about it. And
the wave, yeah.
The wave. Yeah, you can actually see
riding
the wave.
The wave.
There's the Elon Musk wave. There's the who was next? There was another big institutional investor, PayPal, I think. So there's waves that go through the system. So that is really kind of what attracted me too, which is that people have surplus value in energy that they can't utilize. with solar, and it's renewable, and they can utilize that in a way to generate revenue. In a way, you unlock yourself from the concerns about, is it going up or down? You haven't put money in a piggy bank and it's going up or down. You're actually just constantly generating, adding to the blockchain, providing value to the network, helping do the transactions. So you're actually kind of like the good guy, and you're getting some recompense for that.
Yeah, definitely. Yeah, and it provides an opportunity for everyone to get involved. So you don't, you don't need to sign up as a energy producer and go through any of those processes to work on the national energy market. You basically doing it yourself, and it's interesting. I'm really excited to see just the whole industry in 5-10 years and see where it goes with all these new technologies and what's going on. So it's a really good, cool space to be in.
So circling back to Smappee again, from my perspective, Smappee, and there's many control systems. Smappee's a very sophisticated one. It's been in the market for a long time, and so is that Mozzie. Go after Sam. Go after Sam. Is that there's a lot of factors we have to consider, like the price of electricity, the amount of surplus energy we have, the needs that we might have going forward. Like we know we want to charge our car by tomorrow morning to drive 200 kilometers. All of these things, how do we put all that together? Do we sit there with a computer and a program in front of us, or we just let the smarts of IoT and a device like the Smappee genius to solve it for us?
Well, yeah, being a distributor for Smappee, I would definitely say the latter.
I'm going to kind of back announce you here. So, Sam Frost, this is your company, Vista Power.
That's right. Yeah.
So, how did that happen?
I was working, like I said earlier, for a company called Systems Insight, doing load management systems and that sort of things. And Smappee actually approached me via LinkedIn and basically asked whether I was interested in selling their product in Australia. So I was also working with another company called Algadew, who do more commercial style energy meters at the time. And so I after seeing the product and what it does and what they're trying to bring to the market, I was pumped to get involved. And so that's where sort of the business started a couple of years ago now. And basically I guess the idea behind the company is bringing visibility and insights into how people interact with energy in their home or their business. In the past, you'd have to go out and check your meter or wait till you get your power bill every month or quarter to sort of know what you'd been using, or even how much solar you produced and how much you've saved. Whereas with the smart technologies that are available now, you're really putting power back in the consumer's hand and the end user's hand, so that they can gain visibility into all of that. They can make a decision based on seeing their data over the last few days, opposed to waiting 3 months to get that information.
I've noticed that you're rather wedded to your Amber app. You keep checking it to see what the current wholesale price is.
Yeah, that's right. So something else that we're also working on at the moment. So with Smappee being an IoT device and working with other systems, we're actually building an application at the moment to link with the wholesale price of electricity on the national energy market. And so that would allow users to actually create control around when they run certain appliances. So, they may choose to run their pool pump off solar power, or if the price of electricity goes below 10 cents per kilowatt hour overnight. So that's what we're in the process of doing at the moment, and especially for the electric vehicle charging side of things. So you're talking a lot of energy consumption and also potentially high costs. lower cost than gasoline engines, but you're still talking about you're talking about opportunities to save money. With those sort of loads. And so if you could, create rules to say if the price of electricity goes above 18 cents per kilowatt hour, turn off the EV charger, then you're going to generate some pretty decent savings over 12 months.
You mentioned the national electricity market. I actually got that up here on the screen.
Cool.
So for those who are not familiar with the NEM, it's the national electricity market is where energy is bought and sold at a wholesale rate in Australia. And there's a wonderful service. It's free to use. It's called opennem.org.au. And you can actually see on a state base or the whole NEM. So here we go. We're looking at Victoria at the moment, but if you go to some really interesting markets like South Australia, South Australia is one of my favourites because it has an insane amount of renewables. Yellow is solar, green is wind, and look, when it goes below it goes below the dotted line, that means they now have more renewables than they need, and it's being exported. And so this is when negative pricing kicks in, isn't it?
Yeah, that's right. Yeah, we actually get charged to export electricity. And so, I've seen that, you mentioned before, Amber. I use Amber at home, and we have seen the price go negative a few times through summer. Typically, it happens when on a cooler day with a lot of solar energy. So basically, when buildings aren't using their HVAC to cool things down. The good thing with my situation is I've got the Bitcoin miners running, so when that happens, I just switch them all on, and I'm essentially getting paid to use electricity, which is great. It's minus 50 at the moment, so from all sources, a megawatt hour. So that's 5 cents a kilowatt hour. Negative. That means you'd be paid 5 cents just to turn on stuff. That's right. Yeah.
That's insane.
Yeah, it is. It's really interesting. I mean, it's a pity there's the network tariffs there. So, I mean, if you've got a 12 or 14 cent, I think it's about 14 cent network tariff, then it would mean that I think you'd be paying, 7 cents? 7 cents, 9 cents per kilowatt hour. But it's still better than sort of 20, 30 cents. Yeah, definitely.
Yeah, so the NEM's really interesting now. The Energy Web. Tell me what's going on. What's going on here? So
the Energy Web, I've learnt a little bit about it, it seems quite interesting. So it's a blockchain-based, organisation that are working to allow for many different organisations to work together in the energy market. So for buying and selling energy, and also offering services like demand response and that side of things. If you scroll down, you can actually see some of the I think the participants. So you've got some really big names like Siemens, GE, AGL.
TEPCO, so Japan's biggest utility.
Oh, okay. Wow. Yeah.
Yep.
I think there's Engie there as well. Engie are also the owners of EV Box as well, which are an EV charging solution. Oh, they're not.
Wow. Okay. So it's big players. Yeah.
Yeah. Fluvius. So they're I think they're out of Belgium. They do energy, so retail energy metering and that sort of thing. So. So it's another example of how blockchain is being used to open up opportunities and allow more organisations, more people to get involved and to be able to trade services. So that one's it's one that I'm keeping an eye on. They've got their own token as well, so you can actually buy the token on crypto exchanges. So. Definitely, I think one to watch. It's everything's about energy, isn't it? Really, like, our whole lives are based around it. If you didn't have energy, we wouldn't exist. So, so it's definitely a very interesting space to be in and to watch.
Okay, so I'm going to ask the dumb question: what is a blockchain?
Good question. Where's Google? how do you explain it? It's blockchain is it's I believe it's a chain of information. So it's like a database, but that database is shared between multiple devices. So you have a whole network of wallets, and all of those wallets, they hold all of the data that's ever been produced on the network. So instead of having one storage location, like you know traditionally, or even say like 5 where you've got backups and that sort of things, with Bitcoin and other cryptocurrencies, you've literally got thousands and thousands of copies of all of the same data. And if that data changes, if someone tries to push data that's not accepted or doesn't match everyone else's, then they'll reject that, and it won't be able to I guess enter the database. So
you can't fiddle the books.
Exactly, yeah. So once it's there, and you cannot change it. So it's not only like the cryptocurrency side of things, and and the financial side of things, it's also like one of the most secure databases or database technologies that there is available. Like there's no way that you can go in and change the previous data. There's a thing called 51% attacks. So where and it usually happens with cryptocurrencies that don't have a lot of mining or have only just started, and there's only a small amount of wallets and assets on the network, and it's where a group of people can all band together and basically make a change to the network because they've got the 51% majority. But yeah, with Bitcoin, I mean, the chance of that happening is so low because of the distribution of mining and that sort of things.
Okay, let me do my usual thing, which is dumb it down and try and explain it how I understand it. So it's often referred to a blockchain as a distributed ledger. So let's imagine we've got a dual entry ledger, a paper ledger, and we've written transactions in it. Mm-hmm. But at the same time as we're writing it, the copies of that are being sent to everyone else who has a part of that blockchain.
That's right. Yeah. So so you create a transaction, and what happens is it actually gets sent out to the network, and then these things. So the miners actually pick up that transaction, and they will process that transaction, and then there'll also be confirmation. So when you make a transaction, usually rule of thumb is to wait until there's been sort of 6 confirmations of that transaction from different mining parties, and once that's happened, then most of the exchanges and that will release the funds or accept that, and that usually only takes a matter of 10-20 minutes for that to happen. But yeah, so. Sorry, I've lost myself a little bit there.
No, I think you just added to my explanation. So this imaginary paper ledger, which is distributed to everyone who's part of that network of, we're calling it the blockchain, has a copy of that ledger, and there's a machine that's doing the confirmation of that copy. So that's what we're referring to as the miner. If one person tries to change the ledger, all the others will go, no, that's not what's in the ledger, and they reject it. Yeah,
that's right. Yeah, and there's also I'm definitely not an expert on the software side of things and how it works, but I believe that there's also a thing where it will also stop double spending. So it won't allow. So if someone say tries to send funds to one wallet, and then they also try to send the same funds to the next wallet, the way that the network works, it won't allow for that to happen. So it basically, it will invalidate the second one. It'll say, no, we've already got one, and it'll stop that. So the technicalities around how it does it, I'm not totally familiar with, but that's one of the other really cool technologies about it, where you can't double spend, you can't send the same money twice.
So I think the other point to make is that blockchain isn't Bitcoin. Blockchain isn't necessarily about financial transactions. It's a way of validating an agreed change in some information.
That's right. Yeah, it's about creating and storing information and then validating that information across the entire network. So and I mean you've got cryptocurrencies like Ethereum, and that works more like it's like another form of the internet. So you can actually add parameters and code and that sort of things to that blockchain. So it's not just holding digital transactions. It's actually holding data, and so you can build applications that run on that blockchain. So yeah, there's some really cool things, but again, it's starting to get a little bit beyond me, that side of it.
I think it's getting beyond me too, because I've probably had too many of these.
Yeah, that would also do it. Yeah.
But yeah, I hear the word smart contract when everyone says Ethereum. So it's the next level in terms of blockchain. It's not just a record of transactions or data, but it's also it's code as well. And the code can be automatically executed. So you might actually have an agreement which will execute based on conditions, and it can't be modified. So it's kind of like got this sort of rock solid reliability associated with it, and that gives it value too.
And the other thing as well is it would be quite hard to shut any of those cryptocurrencies down because it's distributed. The mining's happening all over the world. One government can't decide, oh, I don't like this cryptocurrency, I'm banning it from the world. They can't do that because it only takes someone on the other side of the world and someone else somewhere else, a network, and you'll continue to have Bitcoin running. So yeah, it's a really, really interesting space, and yeah, geez, to know who came up with it would be really great. Fact
who did come up with the idea of cryptocurrencies? Yeah,
well, that's I think the name is Satoshi Nakamura. And Nakamoto. Sorry. So I know I was thinking about Heroes, the TV series. Hiro Nakamura. Yeah. Yeah, but so to this date, the actual creator of Bitcoin is still unknown, which is well, there he is.
Well, hang on. There he's not. So I love this story. Like, it's veiled in this kind of fog, which is no one actually can confirm it. There's a man called Satoshi, but I think he's got a middle name like Dennis or something, Nakamoto, who lived down the road from a couple of rather clever dudes, or at least one of the dudes, who was very big in cryptography. And many people think that it might be a case of stolen identity, that the actual authors, which may be more than one person, just chose this random professor of mathematics, I think he was, and used his name. Because he doesn't seem to really be the real deal, but he's got the right name. But in a way, it's irrelevant.
You'd think he'd be living a bit of a different lifestyle. So probably somewhere like on a super yacht.
I think the name of the game is to start a cryptocurrency.
Yeah. Well, these days, I mean, get in early is the way to go, isn't it? Because now there's, anyone can create a cryptocurrency now, which is really interesting. You can basically take a copy of, even the Bitcoin software, the program that runs it, and create your own version of that, which is quite interesting. And also talking about Ethereum and the smart contracts and that side of things, is you can also create tokens that run on the Ethereum blockchain. So so you could turn around and say, you want to create this, for instance, Power Ledger, which is an Australian organisation that have done that for energy trading. And so I believe that they run that on the Ethereum blockchain. So they've created a token, and so they use the blockchain, all the mining infrastructure and the processing power of Ethereum to run their token and their business model, essentially. So there's some it's the more you get into it, the more interesting it becomes, which is really cool.
Actually, when you say the word Power Ledger, I have this tremendous feeling of guilt and disappointment because, well, not with them, but with me, which is they came to visit me and they organised to, when I say they, it was someone from Singapore, a couple of people from WA, someone from somewhere else, and they're all coming here just to talk to me. I don't know why. This happens to me every day. But I forgot about the appointment and I was in Melbourne and I get this phone call at the scheduled time, which I'd forgotten. Glenn, we're at your place, but we can't find you.
Oh.
And so I said, I'll be there in 45 minutes. And I rang my neighbour and said, can you make these guys a cup of tea and give them a bit of a tour and show them around? The neighbour came over and showed them around. And I got there in 45 minutes and they were, okay. Thank you, Bindi, my neighbour, for saving the day.
Wow. That's I think I'm more impressed in the fact that, where did you say you were? In Melbourne, and you managed to get here in 45 minutes. That's
maybe it was 55 minutes, but it was a little bit on the eastern side of Melbourne, but I definitely wasn't nearby, so that was a bit of a heart-stopping moment because it was, I respect people's efforts to come and visit me, and then they'd come internationally, and I wasn't there.
Yeah. Oh, it's really interesting what they're doing. I think they're doing some great stuff over in Western Australia and internationally. I mean, they've got a lot of projects running. It's an up and running service and solution. It's just, I think it's one of those things where new technology pops up and it starts going on in the background for 5, maybe 10 years, and then all of a sudden it becomes public knowledge. So it's they're another really good one to watch and see where it all goes.
I believe even banks are using blockchain now. Now, they're not using it for Bitcoin or any other cryptocurrency, they're using it for fiat currency, but blockchain provides them with a way of validating transactions.
Yeah, that's right. So there's I think there's a couple of cryptocurrencies out there that are providing that service. XRP or Ripple is the main one. They're going through some problems, I think, at the moment with the SEC and stuff over in the United States there. But I mean, like we were talking about earlier, the fact that you can send a token or a representation of funds internationally almost instantly. It creates some benefits that aren't seen with the traditional banking system. So I believe even with credit card transactions and that even though the transaction happens straight away, that transaction being completed and finalised in the banking system can take a certain amount of time for that to happen. I think it's 24 hours or something along those lines. So so XRP or the blockchain technology is providing a solution to the banking system to basically improve their services. And there's even I think certain banks that are even bringing out their own currencies now. So it'll be interesting to see how everything goes. I mean, the whole principle, the whole idea about cryptocurrency is that you don't need the banks involved. But we'll see. We'll see how that goes.
You mean there might be Bendo dollars and Sibba dollars and NAB dollars? Yeah,
exactly. I mean, it sounds strange listening to that, but potentially, yeah. It's a strange world, yeah.
Hey, Sam, this has been a great chat. I'm starting to lose my clarity. So I'm thinking it's time to wind
before someone says something embarrassing.
That's right. I did know someone knocking at the door the other day, a few minutes ago, so maybe someone trying to get in here. But yeah, it's been a great chat with you, Sam. So as I said before, I learned quite a bit about the stuff we've been dealing with. I love integrations of systems. I love the, understanding how this can work with that, whether it's, through that platform or just the fact that there are devices like Smappee out there that make it kind of dumb. It's just easy, Well, they
provide
dumb it
that
down.
user-friendly sort of experience. Yeah.
Plug it in and make it work. So, and I have another apology, which is you've provided me with some gear, which thank you very much for that. And I still haven't installed it. Actually, I'm trying to find just the sweet spot for it in terms of its utility. So, the viewers may well see very soon a bit of a Smappee reveal.
Cool.
Yeah, so something a bit more in depth than just you and me chatting.
Well, yeah, I mean, you've definitely got a pretty significant setup out here, and I'd say complicated is it would be a good word to describe it. So finding the right spot for the system, I can see where you're at with that. But I mean, with your electric vehicle charging, maybe you might find a use for it there.
Yeah, cool. All right, well let's take it out. Cheers. Thanks, Sam.
Thanks, Glenn.
Well, thanks, Sam. That was great. Really enjoyed. I certainly enjoyed the spiced rum. That was great. And I'm actually off to a bit of a pirate murder mystery tonight. So yeah, I think rum is probably the order of the day. Anyway, I just want to shout out to everyone about my training courses coming up. If you really enjoy learning about solar and battery design, I've got my 5-day course coming up this week. Now, it's really 4-hour sessions for 5 days, 10 a.m. till 2 p.m. Melbourne time, starting on Monday. The course is aimed at bringing you up to speed with designing a solar and battery storage system. You don't have to be an installer, you don't have to be an expert in that field, but it will take you from the basics through to a complete installation. I've had people like builders do this course, policymakers for government, homeowners, lots of electricians and electrical engineers. So it's a really broad course and it's very interactive. So it's delivered via Zoom meeting, and each day we get together in our virtual classroom and discuss stuff. So that course is running this week. So if you want to join, you can enroll at solarquip.com, my website, and I hope to see you there. Otherwise, I'll see you back on Toolbox Tech Talk next Sunday, 2 p.m. for another rockin' session. Okay, see you guys and girls.